Hello everyone. In this lecture I shall discuss the double integral and consequently I will extend it to the triple integral. So now the double integral over a region, the region R, this is the region R, okay, this is the region R, and over this region we want to evaluate the double integral. So the double integral may be denoted as fxy dy dx, y first then x, or fxy dx dy, x first then y, okay. In any mean we can write. So it can be evaluated by two successive integrations, okay, two successive integrations as follows. So coming to the integral in the left hand side here, suppose the region is specified like this. So if we think that y first, then we have to take a vertical strip here. So this vertical strip here, will give you the limit. So this is the lower limit here. You say this is phi of x, you say this is phi of x, you say this is psi of x, right? This is your y is equal to phi of x, this you say y is equal to psi of x. So now this vertical strip slides from left to right, right? So here this point, you say this is my A point and you say this is my B point. So now this double integral here is integral fxy dy dx. I have told dy dx. So I have told that it is the evaluation of two successive integrals. So here this integral, we have to evaluate this integral first, okay, we have to evaluate this integral first. So what is the limit of this integral? The limit of the integral will vary. It is y is equal to phi x, and here it is y is equal to psi x, okay. So now if you evaluate this integral with respect to y, we treat x is a constant here, x is a constant here. So after this evaluation, this integral will give you, and this vertical strip slides from the left and A point to your B point. So it slides from A to B, right? Left and A to left and B. So now if we evaluate this inner integral, keeping the opposite variable as constant, x is equal to constants. So this integral will take the form here A to B. It will simply a function of x. I can say suppose it is my f of x dx. Now it is a definite integral, okay, and we know how to evaluate it. Suppose the integral is, you say, gx after evaluation from A to B, then this integral will be here gb minus ga, right? This is the idea to evaluate. Now if we think the second type, right, dx first, then in that case we have to consider the horizontal strip, and this horizontal strip slides from the bottom limit here, you say, suppose this limit is my c, say, and my top limit, you say this top point here, you say it is my d here, right? That means the horizontal strip slides from bottom to top, okay. So since dx first, we consider the horizontal, and this integral here will be integral, this is the x first, okay, x, and it is fxy dx, then here dy, and the outer integral here is, this is your c, and this is your c, and this is your d, right? Now here I can say, now the lower limit I can say, suppose it is my some x is equal to some p of y. So here this part, and here I can say that this curve here is x is equal to some q of y. Then this integral will be p of y to q of y. And while we evaluate the inner integral, right, with respect to x, you see this is x, this is opposite variable y, and here this y is treated as a constant here. Now once you evaluate this integral, it will give you integral c to d So in place of x we are substituting py and qy. So it is going to be a function of y only. Function of y only. Now it is a definite integral. If we evaluate it, suppose I say it is my g of y from the limit c to d, then it is gd minus gc. In that way we will evaluate this integral, right? So in both the cases the integral value will same, right? In both the cases the integral value is the same, right? We may proceed like this or we may proceed like this. The value of the integral remains the same, right? The same here, same. Either we may move like this or we may move like this. In each cases the integral will give you the same. So we have to decide whether we will take the vertical strip or horizontal strip looking into the diagram and the easy interpretation. So now before the details of our discussion, let me to introduce myself. Myself Professor Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. So without much delay, let us now see the details of the discussion as follows. Now the double integral can be viewed as follows. You see, suppose I write a to b, here phi x to psi x, it is fxy. You see here, since this is the variable limit, this limit of integration should be opposite, dy then dx. Okay, and I have already told you how to evaluate it. To evaluate it, you first evaluate the inner integral. Keeping the opposite variable means here x is equal to constant here. X is equal to constant here. If you evaluate it, successively we evaluate two integrals. The inner integral, treating x is equal to constant, we integrate with respect to y, and finally in place of y we are substituting function of x. So this will give you a function of x. This will give you a function of x, right? Now we integrate it. After integration, function of x is integrated with to get another function of x with this limit a to b. So this is your gb minus ga, right? Now coming to second, the integral may be viewed as this: a to b sum py to qy, or I can say a to b, no issue. So you have here fxy, you see here. So the variable must be this is y, means this variable must be opposite to this. Okay, now we have to evaluate with respect to x. Then we will evaluate with respect to y. Here we are integrating with respect to this, means the opposite variable, other variable y is constant here. So if we evaluate this integral, this will here a to b, right? This is a function of y only, because we are substituting py and qy here, and we integrate with respect to y. Suppose this integral is here gy say from a to b. So this is gb minus ga. So to the same region, right, this both way of interpretation will give you the same answer, right? To a particular region, both way will interpretation will give you the same answer. Now suppose we have a integral like this. We have a integral like this: integral a to b, integral c to d, fxy, dy dx. So this is the integral given. So here the limit of integration is constant here. How to view this integral geometrically? Means in xy plane we have a region like this. We have a region like this, right? So here we have y first, means we have this is my vertical limit here, the vertical strip here. This is my dy, okay, and here y is equal to c parallel to x axis. Y is equal to c to y is equal to d, right? So this is c to d. Then now it slides from this point is my a. This vertical strip slides from a to b, or if we write it a, right, b, and so that means here the vertical strip from y is equal to c to y is equal to d, and the horizontal slides from this initial point to this terminal point a to b. So now if you think of the coordinate of this, the coordinate of this then this coordinate of this point will be here x-axis A, y-axis C, and x-axis it is B, y-axis C. It is in x-axis A, y-axis D, and here it is x-axis B, y-axis D. So now since the limit is constant, okay, we can view the limit of the integration. It is from A to B. X-axis from the limit of x is A less than x less than B, and limit of y is here C to D. Limit of y is the C to D. C less than y less than D. We can view it like this. However, the real interpretation is like this. We have to take the vertical strip. The lower limit is y equal to C, and this lower upper limit is here y is equal to D, or we simply write C to D. Okay, and in the fourth type, suppose I write integral A to B, integral A to B, integral C to D, fxy dx dy. So what is the interpretation of this? The interpretation here is we have a horizontal strip. This horizontal strip with this on this side, the limit is here x is equal to C, and here x is equal to here D, and the vertical limit it slides from the point A to B. It slides, this is my A, this is my B. Okay, this is means this horizontal strips slides from A to B. Okay, and we may write it. If you think of the coordinate, it is CA DA, and it can be CB DB, right? CB DB, right? That means here x coordinate varies from C to D, C less than x less than D, and y coordinate varies from A to B, right? A less than y less than B. However, the real interpretation is like this. The real interpretation is this is your x is equal to C, this is your x is equal to C, then your x is equal to D, this is your x is equal to D, and the evaluation is the same thing. Means evaluate it treating y equal to constant, then you evaluate it. Now if I let fxy is equal to 1, right? If I set fxy is equal to 1, then in both the cases it will give you the area of this rectangle, right? And if this is my 1 say, and this is my 1 say, okay, 1 say, then it will give you the area of this rectangle, right? Then it will give you the area of the rectangle, right? Area of, if I denote it A, B, C and D, then it is area of ABCD, area of ABCD, okay? And it is also denote the area of ABCD if f of xy is equal to 1. However, in both the cases, right, the value of the integral is remain same. So actually this two way of interpretation will give you the same answer, and it is known as the change of order of integral. Okay, change of order of integral. Change of order of integral means you are given dy dx, right, and you have to evaluate it in the sense of dx dy, or the vice versa. Okay, in the subsequent lecture I will tell you in details. In this lecture I shall just tell you how to evaluate this double integral. Suppose you are asked one example, evaluate integral 0 to 2, integral 2 to 3, x square plus y square dx dy. You are asked to evaluate it. So here this evaluation, so as usual process, successive evaluation, here we treat y is equal to constant here. Okay, so now this will be integral 0 to 2, or treating y is constant. This is integration of x square is x cube by 3 plus y square is constant. Integration of dx is here x. Okay, integration of dx is here x, right? And the limit of integration is 2 to 3. So here this is constant, right? This is here constant. So now if it is function of y, Now it is d of y. Now if you evaluate it, substituting this, what we are getting, it is integral 0 to 2, it is 3 to the power 3, 27 by 3 minus 8 by 3, right, minus 8 by 3. So now coming to this, plus y square remain constant, the value of x is 3 minus 2. Okay, so now it is integrated with respect to y. So this is equal to here integral 0 to 2, 19 by 3 plus y square dy. Now you just evaluate with respect to y. So this will give you 19 by 3y plus y cube by 3 from the limit 0 to 2. And if you evaluate it, it is 19 by 3 into 2 plus 8 by 3. It's 46 by 3. So this is your answer. Okay. So now if this is multiplied, right, if suppose this is multiplied, another example 2 here, suppose you are asked integral 0 to 2, integral 2 to 3, x square into y square dx dy. Okay, then this approach is also fine and you can evaluate it. So this is equal to, you can evaluate it 0 to 2 and 2 to 3, right. Here integrate with respect to x, treating y square is equal to constant, it is x square dx. So now whatever the answer is obtained, you integrate with respect to y. So that is equal to integral 0 to 2, it is y square, it is x cube by 3, it is 2 to 3 dy. So it will be integral 0 to 2 y square by 3, it is 27 minus 8 dy. So it is here 19. So this is equal to integral 0 to 2, right, it is 19 by 3, it is here y square dy, and you evaluate it. So it is 19 by 3 into y cube by 3, right, with this limit 0 to 2. So it is 19 by 9, it is 8 minus 0. So this is 19 into 8 by 9. So now the thing is that, so this will give you 152 by 9. But my intention is to say here, if this is a product type, okay, then we can directly write it. Alternatively, we can directly write it integral 0 to 2x square dx, integral 0 to 3 y square dy, right. Means if this is in multiplied form and the variables are completely separated, x with respect to x, y with respect to y, if you are able to separate it, then it will also give you the same answer. It is x cube by 3 0 to 2 into y cube by 3 0 to 3. So this will give you 8 by 3, it will give you 27 by 3. Actually this limit is from 2 to 3. So it is from 2 to 3. It is 27 by 3 minus here 8 by 3. So it is here 8 by 3 into 19 by 3. So this is 152 by 9. Okay. So if you are in a position to separate the variables completely, x with respect to x and y with respect to y, then only this way also possible. Okay. However, the general approach is like this. Successively you integrate it. Now coming to one important example. Example 3. Evaluate integral 1 to 5 integral 0 to x square 1 plus 2x e to the power x plus y dy dx. Okay. So now coming to the solution. If you evaluate it, so now you see, if you evaluate it, let I is equal to, let my I is equal to integral 1 to 5 integral 0 to x square 1 plus 2x e to the power x plus y dy dx. So first I evaluate with respect to y here. So this is equal to, I can write it, this is equal to, I can write it integral 1 to 5 with respect to y first. So this is constant. 1 plus 2x e to the power x into e to the power y taken out, and it is 0 to x square e to the power y dy, right? Then dx. Okay, so here you just evaluate it. So this is your 1 to 5, 1 plus 2x e to the power x, it is e to the power y 0 to x square dx. So now this is equal to 1 to 5, 1 plus 2x e to the power x, and it is here e to the power x square minus e to the power 0 is here 1 dx. So this is equal to multiply this with this and this with this. Integral 1 to 5, 1 plus 2x e to the power x plus x square minus integral 1 to 5, 1 plus 2x e to the power x dx. Okay, now you see, if I substitute this is equal to my t, then this is my dt. So it is my integral 1 to 5 d of x plus x square, is not it? Minus I apply by parts here, minus here 1 plus 2x integral of e to the power x is e to the power x minus derivative of this is 2 integral of this is e to the power x, and subsequently if I differentiate it, it will 0. Okay, so now this is from my 1 to 5, this is from my 1 to 5, 1 to 5. Then if I substitute it, so this will be my, this is e to the power, sorry, d of e to the power this. So it is e to the power x plus x square from 1 to 5 minus here 2x e to the power x and this minus e to the power x from the limit 1 to 5. And if I substitute the upper limit minus lower limit, and it will be here, e to the power 30, it will be here e to the power 30 minus e to the power 2 minus, if I take common e to the power x, it is 2x minus 1 from the limit 1 to 5. So it is e to the power 30 minus e square minus 9 e to the power 5 plus e. This will be your answer. Okay. Now in the same line, we will able to extend it to triple integral, right? Extension to triple integral. So the interpretation is same here, means you are asked to evaluate the triple integral over a region f x y z dy dz dy dx, and now this can be changed, this order can be changed. Okay, so now this can be viewed as integral, suppose a to b integral, suppose I want to evaluate with respect to z here first, f x y z dz. So while I evaluate with respect to z, okay, here y and x and y are constant, and this limit with respect to z means it may be a function of other two variables xy and function of other two variables. So now this should be the limit of your z, right? Then your limit of y may be a function of x, right? Then the limit of the last one, it is your z, then your y, then your x. Okay, now if you evaluate it, if you evaluate the inner integral, then this will give you a to b, now it is px to qx. Now this will give you a function of, there will be no z, it will be a function of xy, dy dx. Now it reduced to a double integral, okay. So you should see that if this is z, this limit of integration involve the other variables, right? Now once it is a double integral, you know what to do then it is here, a to b, you evaluate it, treat here x is equal to constant, so then it is a function of x only, right? Then it is a function of, now if you integrate it, so g of x will be, suppose my h of x, it is my hb minus ha, right? So this is what the triple integral is, the same way of interpretation as the double integral. Now coming to the properties of the integral. Now coming to the properties of the double integral, if f and g are two continuous functions in a region R, then a double integral over R constant into the function f dx dy, constant can be taken out of the integration, it is f dx dy. F is a function of x and y. Similarly, coming to property number 2, if you want to, you have plus and minus, f plus minus g dx dy, plus or minus, then it can be separately integral of f dx dy plus integral of f d here g dx dy. Okay, now if this is dx dy, then this will continue, right? Then coming to the property number 3, suppose you are asked to evaluate the integral f dx dy. So now this region f is, suppose the region f is splitted into two regions. This entire is my R, this is my R1 region and this is my R2 region. Okay, so then it will be my integral over R1 region plus integral over R2 region. It is f and it is f dx dy. It is dx dy. Okay, so in that way. Now fourth one is the most important property. So this is let x0 y0 be a point in R. Okay, then you can write it integral R fxy dx dy or dy dx. It will be double integral over R f of x0 y0, right, dx dy. The moment it is a constant now, it can be taken out, so this will be double integral over R. It is f of x0 y0 taken out. Okay, so this is here f of x0 y0 taken out, it is dx dy. Now this can be interpreted as the area of the region. So this is equal to f of x0 y0 into a. A is the where a is the area of the region R. Okay, so in that way, actually this is known as the mean value theorem for double integral. Okay, so this is known as the mean value theorem for the double integral, Okay, so to conclude, the double integral can be viewed as the two successive integrals. Okay, and for the better implementation of the result, you should have the geometrical idea, so that there will be no error in evaluation of the limit. Okay, so it is better to plot the diagram and accordingly take the strip horizontal or vertical as per the convenience, and you evaluate it as two successive integrals. Okay, and you should solve these examples along with a few more problems from a standard book. So we should close this lecture here. The video is getting lengthy, so thank you all. Now at this stage I have one request. If you feel that this lecture is useful and helpful for you, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. At the same time, the same lecture will be displayed in your screen, which will be easier for you to access as and when required. Okay, thank you all. Have a nice day.